So, how do we go from a simple chatbot to an AI that can actually do things for you in the real world? Well, that's exactly the journey we're going on today. We're going to take a powerful but totally isolated AI brain and turn it into a smart agent that can see your data, remember what you've talked about, and use tools to get real work done. Let's dive in.
Here's our game plan. First, we're going to break the AI out of its box and hook it up to some data. Then we'll build a basic question and answer chain, see exactly where it falls short, and then give it a major upgrade with a much smarter workflow using something called LangGraph. And finally, we'll put all those pieces together to build our very first fully functional AI agent.
Okay, so here's the fundamental problem we're trying to solve. You've got this large language model, an LLM, and it's basically a genius brain. But that brain is stuck in a jar. It's completely isolated. It has no eyes, no ears, no hands. It can't see your private files, and it has no idea what's happening in the world right now. Our entire goal is to pop the lid off that jar.
So first up, let's really get to grips with this whole confined genius idea. We have to understand what an LLM can't do right out of the box before we can start building the cool stuff that lets it overcome those limits.
This right here perfectly sums up the transformation we're after. On the left, that's your standard LLM, a brain in a jar. It knows a ton of general information from its training data, but that's it. On the right, that's our goal, a connected AI. A brain with senses and tools, one that can look at real-time data and even query your company's private databases. It's the difference between a know-it-all and a do-it-all.
Right, so how do we even start to get that AI out of its jar? The very first step, the most crucial one, is giving it senses. We need to give it a connection to the outside world. This is its first contact with your unique data. And for this data connection, there are really two main paths you can take. The first one is for structured data. Think of nice, neat, organized spreadsheets or databases, like a graph database, where we can ask for very specific facts. The second path is for all the messy stuff, unstructured data, like a big pile of PDFs or random articles. For that, we use a really cool technique called retrieval augmented generation. You might have heard of it as RAG, to search through everything and find the most relevant bits. So let's tackle that first path, structured data. We're going to connect our AI to a graph database and build a really simple, straight-line process to ask it questions and get answers back.
This diagram shows the whole thing perfectly. It's like a three-step assembly line. First, the LLM acts as a translator. It takes a normal human question, like who acted in the movie Casino, and turns it into a specific database language, in this case, Cipher. Now, this is a huge deal because it means you don't need to be a programmer to ask complex questions of your data. Step 2, that query gets run on the database. And finally, Step 3, the LLM takes the raw data that comes back and translates it into a normal, human-friendly answer.
And here's the really wild part. That entire three-step process we just walked through, you can set it all up with just one line of code in a framework like LangChain. You just call graph cipher QA chain, and you've instantly created that whole workflow. It's an amazing example of how these tools hide all the complexity for you. But, the real world is messy. What happens if the LLM messes up and creates a bad query? Or what if you want to ask a follow-up question? This simple one-way street just breaks. It's stateless, which is a fancy way of saying it has zero memory of what just happened, and it can't handle mistakes. We need something a lot smarter. And that brings us to the next big evolution, LangGraph. If that simple chain was like a single muscle, LangGraph is the nervous system that controls everything, letting us build complex, intelligent, and flexible workflows.
The big idea here is that LangGraph lets us stop thinking in a straight line and start building something that looks more like a flowchart. Each box, or node, is an action, like generate a query, and the arrows between them, the edges, contain the logic. This means if a query fails, we don't just give up. We can build a loop that says, hey, if there's an error, go back and try again a different way. This is how we build stateful apps that actually remember what happened before.
And this table just makes the difference crystal clear. A simple chain, it's stateless and linear. It forgets everything the second it's done. A LangGraph workflow, on the other hand, is stateful and cyclical. It can remember past conversations, it can handle errors like a champ by rerouting to a correction step, and it can juggle really complex multi-step reasoning. It is a massive, massive upgrade.
So how does it pull off this memory trick? Well, it uses a key component called a check pointer. Honestly, the best way to think about it is like an autosave feature for the AI's brain. By using something like Memory Saver, LangGraph can store the entire history of a conversation. That's what allows the AI to have these really aware, multi-step dialogues. So now that we have this smart, stateful workflow, we can finally take the last big leap from an AI that just answers our questions to one that can actually do things for us. This is the rise of the agent.
An agent is really the final form of everything we've built so far. It uses the LLM not just to create text, but as its main reasoning engine. The agent isn't just following a rigid set of instructions anymore. It's looking at a goal and then deciding for itself which tool, like a web search or a database query, is the right one to use to get the job done.
And this whole process is driven by a simple but powerful loop, often called REACT, which stands for reason and act. It's a constant cycle. First, the LLM reasons about the problem. Then it acts by choosing and using a tool. It then observes the result from that tool, and that result gets fed back into the loop to kick off the next round of reasoning. It just keeps repeating this cycle, reason, act, observe, over and over until the job is done.
And hey, don't just take my word for it. This quote from the source material nails it. Agents leverage the reasoning capabilities of LLMs to make decisions during execution. They're not just following a script, they are thinking and making decisions on the fly.
And what's awesome is, once again, the framework makes this super accessible. That whole complex React loop we just talked about, you can spin one up with a single function call in LangGraph, create_React agent. You just give it the model and tell it what tools it can use, and it wires up that entire reasoning loop for you.
All right, we have covered a ton of ground. So let's put all these ideas together and look at the essential recipe for building our very first agent.
So what do we actually need in our toolkit? First, you need a model. That's the brain. Second, you need a set of tools. Those are the hands. Third, you need memory, using that checkpointer we talked about so it can actually have a conversation. And finally, you need an executor. That's the runtime that brings it all to life and keeps that core reasoning loop spinning.
Let's make this super concrete with an example. A user says, "Hi, I'm Bob, and I live in SF." The agent uses its reasoning brain, realizes no special tool is needed, and just says, "Hi" back. But then the user asks, "What's the weather where I live?" Now, the agent connects the dots. It uses its memory to recall that where I live means San Francisco, and it decides the right action is to use its search tool to look up the weather there. That is memory and tools working together perfectly.
So why is this all such a big deal? Because we've officially moved way beyond simple chatbots. With this kind of architecture, you can build AI applications that don't just talk, they act. They become these autonomous assistants that can analyze your data, automate your web searches, or tap into any API you give them access to. This is going to fundamentally change how we get things done.
We've just walked through the entire blueprint, taking an AI from being an isolated brain in a jar to a fully capable agent with memory and tools. So the only real question left is, now that you have the plan, what amazing things are you going to build with your first agent?